The ocean, a vast and seemingly boundless expanse, is far from static. Beneath its surface lies a complex network of currents, ever flowing like rivers within the sea. These currents, driven by a combination of forces, play a crucial role in shaping our planet's climate, influencing weather patterns, and supporting a wealth of marine life. Their influence extends far beyond the ocean's edge, impacting the lives and livelihoods of people across the globe. Imagine the ocean as a giant engine, constantly circulating heat and nutrients around the planet. Ocean currents are the gears of this engine, transferring thermal energy from the tropics towards the poles and bringing colder water from the depths to the surface. This continuous movement helps to regulate Earth's temperature, making our planet habitable. Understanding ocean currents is not just an academic pursuit. It is essential for comprehending the intricate web of life on Earth, predicting future climate scenarios, and managing our planet's resources sustainably. By delving into the depths of these underwater rivers, we gain a deeper appreciation for the interconnectedness of our world and the profound influence these unseen forces have on our lives. As we embark on this journey to unravel the mysteries of ocean currents, we will explore their origins, their evolution over time, and the intricate dance they perform with weather, seasons, and climate. Join me as we dive into the depths of this fascinating subject and uncover the profound impact these currents have on our planet and our lives.
The birth of an ocean current is a result of a delicate interplay between various natural forces. It is a symphony of wind, density, gravity, and the Earth's rotation, all working in concert to set these underwater rivers in motion. One of the primary drivers of surface currents is the wind. As wind blows over the ocean's surface, it creates friction, dragging the water along with it. These wind-driven currents, like the powerful Gulf Stream and the Kuroshio Current, transport vast amounts of heat across the globe. Differences in water density, caused by variations in temperature and salinity, also play a crucial role in driving ocean currents. Warmer, less salty water is less dense and tends to rise, while colder, saltier water sinks. This creates a vertical circulation pattern known as thermohaline circulation, a slow but powerful engine driving the ocean's conveyor belt of currents. The Earth's rotation adds another layer of complexity to ocean currents. The Coriolis effect, caused by the planet's spin, deflects moving objects, including water, to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection influences the direction and flow patterns of major ocean currents. Finally, gravity plays a crucial role in shaping ocean currents. Variations in sea level, caused by factors like wind and differences in water density, create pressure gradients. Water flows from areas of high pressure to areas of low pressure, influencing the direction and strength of currents. The intricate interplay of these forces creates a complex and dynamic system of ocean currents that constantly evolves and adapts to changing conditions. Understanding these driving forces is key to comprehending the behavior of ocean currents and their impact on our planet.
Ocean currents are constantly evolving, shifting, and adapting to changing conditions over time. Their evolution is a complex dance through time, influenced by geological events and climate cycles. Tectonic plate movement has significantly shaped ocean currents. The breakup of continents altered ocean basins, influencing current pathways. Climate change, past and present, exerts a powerful influence on ocean currents. Rising temperatures and melting glaciers impact ocean temperatures, salinity, and wind patterns. Natural cycles like El Niño and La Niña contribute to the variability of ocean currents. Understanding ocean currents is crucial for predicting their response to future climate change.
Section 4. The breadth of atmosphere, weather, and the currents. The relationship between ocean currents and weather is a dynamic two-way street, with each influencing the other in a complex interplay. Ocean currents act as massive heat distributors, influencing air temperature, humidity levels, and the formation of weather systems. Warm ocean currents, like the Gulf Stream, act like giant radiators, releasing heat into the atmosphere and moderating temperatures in coastal regions. This explains why Western Europe, despite its high latitude, enjoys relatively mild winters compared to regions at similar latitudes. Conversely, cold currents, like the California current, can lead to cooler and drier conditions along coastlines. Ocean currents also influence the distribution of moisture in the atmosphere. Warm currents, carrying large amounts of water vapor, fuel the formation of clouds and precipitation. As these currents encounter cooler air masses, the moisture condenses, leading to rainfall and storms. This explains why coastal regions near warm currents often experience higher levels of rainfall. The interaction between ocean currents and the atmosphere can also give rise to extreme weather events. For instance, El Niño events, characterized by warmer than average sea surface temperatures in the equatorial Pacific, can disrupt normal weather patterns, leading to droughts in some regions and floods in others. The influence of ocean currents on weather is not limited to coastal regions. These currents can influence atmospheric circulation patterns on a global scale, impacting weather systems thousands of miles away. By understanding the complex interplay between ocean currents and the atmosphere, we can better predict weather patterns, prepare for extreme events, and appreciate the interconnectedness of Earth's systems.
Section 5. Seasons change, currents shift, a delicate balance. The ebb and flow of seasons bring about changes not only on land, but also in the vast expanse of our oceans. Ocean currents, sensitive to the seasonal dance of the sun, undergo subtle yet significant shifts in their patterns, influencing marine life and coastal weather. One of the primary ways seasons affect ocean currents is through changes in solar radiation. During summer, increased sunlight warms the surface waters, leading to the formation of a warm layer at the top of the ocean. This warm layer, separated from the colder, denser water below by a thermocline, can influence the strength and direction of surface currents. Seasonal changes in wind patterns also play a role in shaping ocean currents. For example, monsoonal winds, driven by the temperature differences between land and sea, can reverse the direction of ocean currents in certain regions, like the Indian Ocean, leading to dramatic shifts in marine productivity and weather patterns. As seasons transition, so too does the intensity of upwelling and downwelling, processes that transport nutrients and oxygen between the ocean's surface and depths. During spring and summer, upwelling brings nutrient-rich water from the depths to the surface, fueling plankton blooms that form the base of marine food webs. The delicate balance between seasons and ocean currents highlights the intricate connections within Earth's systems. These seasonal shifts in ocean circulation patterns have profound implications for marine ecosystems, coastal communities, and the global climate system. Understanding these dynamics is crucial for managing fisheries, predicting weather patterns, and mitigating the impacts of climate change.
Section 6. Climate change and currents, a relationship in flux. The relationship between ocean currents and climate change is a complex and concerning one. As our planet warms due to human activities, the delicate balance of ocean currents is being disrupted, with potentially far-reaching consequences for our climate system and the health of our oceans. One of the most significant impacts of climate change on ocean currents is the melting of glaciers and ice sheets. The influx of fresh water from melting ice is altering the salinity and density of ocean water, potentially slowing down the thermohaline circulation, the conveyor belt that drives deep ocean currents. This slowdown could have significant implications for global heat distribution and regional climate patterns. Rising ocean temperatures, driven by the absorption of excess heat from the atmosphere, are also influencing ocean currents. Warmer water is less dense and tends to stratify, potentially weakening the upwelling of nutrient-rich water from the depths. This could disrupt marine food webs and impact fisheries that rely on these nutrient-rich waters. Changes in wind patterns, influenced by shifting atmospheric circulation patterns due to climate change, are also altering the strength and direction of wind-driven ocean currents. These changes can impact the distribution of heat and nutrients in the ocean, affecting marine ecosystems and weather patterns. The impacts of climate change on ocean currents are still an active area of research, but the potential consequences are significant. Disruptions to these vital currents could lead to more extreme weather events, rising sea levels, and significant changes in marine ecosystems. Understanding and mitigating these impacts is crucial for safeguarding the health of our oceans and ensuring a sustainable future for our planet.
Chapter 7. The role of ocean currents in marine life. Ocean currents play a crucial role in the distribution of nutrients and marine life. They help transport plankton, which forms the base of the marine food web, to different parts of the ocean. This chapter will explore how ocean currents affect marine biodiversity and the health of marine ecosystems. Ocean currents act as the lifeblood of our oceans, circulating essential nutrients that sustain a diverse array of marine life. As currents move through the ocean, they carry with them microscopic organisms such as phytoplankton, which are the primary producers in marine ecosystems. These tiny plants rely on sunlight and nutrients to thrive, and ocean currents ensure that they are distributed to areas where they can flourish. Plankton, both phytoplankton and zooplankton, form the foundation of the marine food web. They are consumed by small fish and invertebrates, which in turn are preyed upon by larger fish, marine mammals, and seabirds. Without the movement of ocean currents, these vital organisms would not reach the areas where they are needed most, leading to a decline in marine biodiversity and the health of entire ecosystems. In addition to transporting nutrients and plankton, ocean currents also play a role in regulating the temperature of marine environments. Warm and cold currents create distinct habitats that support different species of marine life. For example, cold currents bring nutrient-rich waters to the surface, supporting large populations of fish and other marine animals. Warm currents, on the other hand, can create more stable environments where coral reefs and tropical fish thrive. The upwelling of deep, nutrient-rich water to the surface is another critical function of ocean currents. This process brings essential nutrients from the ocean floor to the surface, where they can be utilized by phytoplankton and, subsequently, the entire marine food web. Areas of upwelling are often among the most productive and biodiverse regions of the ocean, supporting thriving fisheries and vibrant ecosystems. However, as we have seen in previous chapters, climate change poses a significant threat to the delicate balance of ocean currents. Changes in temperature, salinity, and wind patterns can disrupt the flow of currents, leading to a decline in nutrient availability and impacting marine life. It is essential that we continue to study and understand these complex interactions to protect the health of our oceans and the diverse life they support. Ocean currents are the unsung heroes of marine ecosystems, driving the processes that sustain life beneath the waves. By appreciating their importance and working to mitigate the impacts of climate change, we can help ensure a vibrant and healthy future for our oceans and the countless species that call them home. Chapter 8: Human Impact on Ocean Currents. As the intricate dance of ocean currents continues beneath the surface, human activities cast an ever-growing shadow over these natural processes. Climate change, pollution, and overfishing are not only altering the flow of currents but also threatening the delicate balance of marine ecosystems and, by extension, our own survival. Climate change is perhaps the most profound disruptor of ocean currents. Rising global temperatures lead to the melting of polar ice caps, which in turn increases the volume of freshwater entering the oceans. This influx of fresh water alters the salinity and density of seawater, which are critical factors in the formation and movement of ocean currents. As these patterns shift, the distribution of nutrients and marine life is affected, leading to unpredictable changes in the health and diversity of marine ecosystems. Pollution, particularly from plastics and chemical runoff, further exacerbates the problem. Microplastics have been found even in the deepest parts of the ocean, carried there by currents. These pollutants can harm marine life directly through ingestion and entanglement, and indirectly by disrupting the food web. Chemical pollutants, such as oil spills and agricultural runoff, create dead zones where oxygen levels are so low that most marine life cannot survive. These areas can disrupt the natural flow of currents and further degrade marine habitats. Overfishing adds another layer of complexity. By removing significant amounts of fish from the ocean, we disrupt the balance of marine food webs. This can lead to the overpopulation of certain species and the decline of others, affecting the overall health of marine ecosystems. Moreover, the removal of large predatory fish can alter the behavior of smaller fish and invertebrates, which in turn affects the movement of nutrients within the ocean. The consequences of these human impacts extend beyond the ocean. As currents change, so too does the climate. Ocean currents play a vital role in regulating the Earth's climate by distributing heat around the globe. Disruptions to these currents can lead to extreme weather events, such as hurricanes and droughts, which have devastating effects on human societies. It is crucial that we recognize the interconnectedness of our actions and the health of our oceans. By reducing our carbon footprint, limiting pollution, and managing fisheries sustainably, we can help preserve the natural flow of ocean currents and the ecosystems they support. The future of our planet depends on our ability to understand and mitigate the impacts of human activities on these vital systems. Human impact on ocean currents is a stark reminder of the power we wield over the natural world. By acknowledging this influence and taking steps to minimize our footprint, we can help ensure a balanced and thriving ocean for generations to come. As we grapple with the profound impacts of human activity on ocean currents, technology offers a beacon of hope. In this chapter, we explore the cutting-edge advancements that have revolutionized our understanding of these vital systems. Satellite imagery has become an indispensable tool in monitoring ocean currents. From space, satellites equipped with advanced sensors provide real-time data on sea surface temperatures, wave heights, and current patterns. These high-resolution images allow scientists to track the movement of currents over vast distances and timescales, offering insights that were once unimaginable. Underwater drones, or autonomous underwater vehicles, AUVs, have opened new frontiers in oceanography. These sophisticated machines navigate the depths of the ocean, collecting data on temperature, salinity, and other key parameters. Equipped with cameras and sensors, AUVs can explore areas that are difficult or dangerous for human divers to reach, providing a detailed picture of the underwater world. Acoustic Doppler current profilers, ADCPs, are another vital tool in the study of ocean currents. These instruments use sound waves to measure the speed and direction of water flow at various depths. Mounted on ships or deployed on the ocean floor, ADCPs offer continuous and precise measurements, helping scientists to understand the dynamics of currents in different regions. The integration of big data and artificial intelligence, AI, is further enhancing our ability to analyze and interpret oceanographic data. By processing vast amounts of information from multiple sources, AI algorithms can identify patterns and trends that might otherwise go unnoticed. This capability is crucial for predicting changes in ocean currents and their potential impacts on marine ecosystems and climate. Collaboration between international organizations and research institutions is also playing a critical role. Initiatives like the Global Ocean Observing System, GOS, bring together data from satellites, buoys, and other monitoring stations around the world. This collective effort provides a comprehensive and coordinated approach to studying ocean currents, ensuring that scientists have access to the most accurate and up-to-date information. These technological advances are not just academic exercises, they have real-world applications. Improved forecasting of ocean currents can enhance maritime navigation, optimize shipping routes, and mitigate the risks of natural disasters. By understanding how currents influence weather patterns, we can better prepare for extreme events and protect vulnerable communities. Moreover, these tools are essential for conservation efforts. By mapping critical habitats and monitoring the health of marine ecosystems, scientists can develop targeted strategies to protect and restore the ocean's biodiversity. Technology empowers us to make informed decisions and take proactive steps to safeguard the future of our oceans. In the face of unprecedented challenges, the marriage of technology and science offers a pathway to resilience. As we continue to innovate and expand our knowledge, we move closer to a sustainable balance with the natural world. The study of ocean currents is a testament to human ingenuity and our capacity to adapt and thrive in harmony with the planet. As we stand on the cusp of a new era, the future of ocean currents beckons with both promise and uncertainty. The shifting climate, driven by human activity, will inevitably alter these ancient flows, reshaping the world in ways we are only beginning to understand. Climate models predict significant changes in ocean currents over the coming decades. The warming of the planet is expected to intensify surface currents in some areas, while weakening them in others. The melting of polar ice caps and glaciers is pouring fresh water into the oceans, altering salinity levels and disrupting the delicate balance that drives current circulation. One of the most profound impacts of these changes is on global climate patterns. Ocean currents play a crucial role in regulating temperatures by distributing heat around the planet. As these currents shift, so too will weather patterns, potentially leading to more extreme and unpredictable weather events. Coastal regions may experience more intense storms and flooding, while other areas may face prolonged droughts and heat waves. Rising sea levels, driven by both thermal expansion and the influx of freshwater, pose another significant threat. Low-lying coastal communities and island nations are particularly vulnerable, with millions of people at risk of displacement. The alteration of ocean currents could exacerbate these effects, leading to more frequent and severe coastal erosion and inundation. The future of ocean currents also holds implications for marine life. Many species rely on specific current patterns for migration, breeding, and feeding. Changes in these patterns could disrupt ecosystems, leading to shifts in species distribution and abundance. Some marine organisms may struggle to adapt, while others could thrive in the new conditions, potentially leading to imbalances in marine biodiversity. Human life and livelihoods will be deeply affected by these changes. Fisheries, which depend on the health and stability of marine ecosystems, may face declines in fish stocks and shifts in species composition. Coastal economies that rely on tourism and marine resources will need to adapt to the new realities of a changing ocean. Yet, amidst these challenges, there is hope. By leveraging the technological advances we have discussed, we can improve our understanding and prediction of ocean currents. This knowledge is crucial for developing adaptive strategies to mitigate the impacts of climate change. International cooperation and proactive policies will be essential in managing the future of our oceans. The future of ocean currents is a story still being written. It is a narrative shaped by the choices we make today. By embracing innovation, fostering collaboration, and committing to sustainability, we can navigate the uncertainties ahead and work towards a resilient and harmonious relationship with the natural world. As we look to the horizon, let us remember that the currents of change are within our grasp. Together, we can steer the course towards a future where both humanity and the oceans can thrive. As we reflect on the future of ocean currents, it is essential to look back at the history of ocean exploration, a journey that has shaped our understanding of these complex and vital flows. The story of ocean exploration is one of curiosity, bravery, and relentless pursuit of knowledge. Our voyage begins in ancient times when early civilizations like the Phoenicians and Greeks first ventured into the unknown waters. These early explorers relied on stars, wind patterns, and rudimentary maps to navigate the seas. Their quests laid the groundwork for future generations, demonstrating that the oceans were not boundaries but gateways to discovery. Fast forward to the age of exploration in the 15th and 16th centuries. Visionaries like Christopher Columbus, Vasco da Gama, and Ferdinand Magellan undertook daring voyages that expanded the known world. Their expeditions revealed the vast expanse of the oceans and the intricate web of currents that connect distant lands. These discoveries were instrumental in the development of global trade routes and cultural exchanges. The 19th century marked a significant leap forward with the advent of scientific oceanography. The voyage of HMS Challenger from 1872 to 1876 was a groundbreaking expedition that systematically studied the world's oceans. This pioneering journey provided the first comprehensive data on ocean currents, temperature, and marine life, laying the foundation for modern oceanography. As technology advanced, so did our ability to explore the depths. The invention of sonar, submersibles, and remote sensing tools in the 20th century opened new frontiers in ocean research. Expeditions like the deep-sea dives of the Trieste and the revolutionary explorations of Jacques Cousteau brought the mysteries of the deep to the surface, captivating the imagination of the world. Today, ocean exploration continues to evolve, driven by cutting-edge technologies and international collaboration. Satellites, autonomous underwater vehicles, and sophisticated computer models allow us to monitor and understand ocean currents with unprecedented precision. These tools are essential for predicting changes and mitigating the impacts of climate change on our oceans. The history of ocean exploration is a testament to human ingenuity and determination. It is a chronicle of how curiosity has propelled us to push the boundaries of what is known and venture into the unknown. As we chart the future of ocean currents, we are guided by the legacy of those who came before us, their discoveries illuminating the path ahead. In this ever-evolving narrative, the oceans remain a frontier of endless possibilities. By continuing to explore, understand, and protect these vast waters, we honor the past and secure a sustainable future for generations to come. To fully appreciate the intricate dance of ocean currents, we must delve into the scientific principles that govern their movement. These currents are not random. They are orchestrated by a combination of forces that work together to create the vast and dynamic oceanic system we observe today. One of the key principles is the Coriolis effect. This phenomenon arises from the rotation of the Earth and affects the direction of moving fluids, including air and water. In the northern hemisphere, the Coriolis effect causes currents to veer to the right, while in the southern hemisphere, they veer to the left. This deflection plays a crucial role in shaping the large-scale patterns of ocean currents. Next, we explore thermohaline circulation, often referred to as the global conveyor belt. This process is driven by differences in water density, which are influenced by temperature and salinity. Warm, salty water from the equator travels toward the poles where it cools and sinks, creating a deep water current that flows back toward the equator. This continuous movement helps regulate the Earth's climate by redistributing heat across the planet. Wind patterns also significantly impact ocean currents. The trade winds, westerlies and polar easterlies create friction on the ocean's surface, generating currents that flow in predictable patterns. For example, the trade winds drive the equatorial currents while the westerlies influence the mid-latitude currents. These wind-driven currents are essential for transporting nutrients and heat across the oceans. Animations and diagrams can vividly illustrate these concepts, making the science behind ocean currents more accessible and engaging. Visual representations of the Coriolis effect, thermohaline circulation, and wind patterns can help us understand how these forces interact to create the complex and interconnected system of ocean currents. By comprehending the science behind ocean currents, we gain a deeper appreciation for the delicate balance that sustains life on Earth. These currents are not merely movements of water, they are vital components of the global climate system, influencing weather patterns, marine ecosystems, and even human activities. As we continue to study and understand these scientific principles, we enhance our ability to predict and respond to changes in our oceans. This knowledge is crucial for developing strategies to protect and preserve the health of our planet for future generations. In the grand tapestry of Earth's natural systems, ocean currents are a testament to the intricate and interconnected nature of our world. By unraveling the science behind these currents, we unlock the secrets of the seas and deepen our connection to the planet we call home. As we continue our journey through the mysteries of the ocean, we arrive at a pivotal topic: how ocean currents influence global climate patterns. These mighty rivers of the sea play a critical role in regulating temperatures and affecting weather systems around the globe. As our exploration of ocean currents continues, we turn our gaze to the horizon, contemplating the future challenges and opportunities that lie ahead. The impact of climate change on these vital systems is profound, altering the very fabric of oceanic circulation. Rising temperatures and melting ice caps introduce uncertainties that scientists are racing to understand. Technological advancements are our beacon of hope. From sophisticated satellite monitoring to autonomous underwater vehicles, these innovations offer unprecedented insights into the complexities of ocean currents. The integration of artificial intelligence and machine learning is revolutionizing our predictive capabilities, providing us with tools to forecast changes with greater accuracy. Yet the study of ocean currents is not a solitary endeavor, it demands a united front. International collaboration has never been more crucial as nations come together to share data, expertise, and resources. This collective effort fosters a deeper understanding and paves the way for global solutions. We hear from leading experts who share their visions and predictions. Dr. Emily Carter, an oceanographer, emphasizes the need for sustained investment in research and technology. The future of our oceans depends on our willingness to innovate and cooperate, she states. Dr. Raj Patel, a climate scientist, highlights the importance of education and public awareness. Empowering the next generation with knowledge and tools is essential for the preservation of our marine ecosystems, he asserts. As we navigate the uncharted waters of the future, the challenges are daunting, but the opportunities are boundless. Together, we can safeguard the lifeblood of our planet, ensuring a harmonious relationship between humanity and the ever-flowing rivers of the sea. Join us as we continue this journey, diving deeper into the marvels and mysteries of our oceans. As we come to the end of our journey through the ever-flowing rivers of the sea, let's take a moment to reflect on the key points we've discussed. We've delved into the symphony of forces that drive ocean currents and explored their dance through time. We've seen how weather patterns and ocean currents are intricately linked, maintaining a delicate balance that sustains marine life and impacts global climate. We've witnessed the profound influence of human activities on these vital systems and the groundbreaking technological advances that are aiding our understanding and preservation efforts. From satellite monitoring to autonomous underwater vehicles and the integration of artificial intelligence, our tools are becoming ever more sophisticated. International collaboration has emerged as a cornerstone of our efforts, with nations around the world coming together to share data, expertise, and resources. The voices of leading experts have underscored the importance of sustained investment in research, technology, and education. But now, we must turn our knowledge into action. The future of our oceans hinges on our collective commitment to conservation. It's time for each of us to play a part in this global effort. Whether it's reducing plastic waste, supporting sustainable fishing practices, or advocating for stronger environmental policies, every action counts. Let's draw inspiration from the incredible conservation projects happening around the world. From coral reef restoration initiatives to beach cleanups, communities are coming together to make a difference. We can all contribute to these efforts, no matter where we are. So, let's rise to the challenge and seize the opportunities before us. Join us in safeguarding the lifeblood of our planet. Together, we can ensure a harmonious relationship between humanity and the ever-flowing rivers of the sea. Thank you for joining us on this journey. Stay curious, stay informed, and most importantly, stay active in the fight to protect our oceans.